If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello, my name is James and I'm the Bald Engineer. Welcome to an AddOhms live stream. If this is your first time, we do electronics stuff on this channel, and in this live stream I'm going to be checking out a new board I just got in the mail. You should know that this is streamed in multiple places, so on YouTube, on Twitch, and today I'm trying out for the first time on Facebook. All of those locations show up in the chat box that's over here. Or maybe this chat box over here. So you can chat from any of those places. Also know that we have a Discord server so we can keep the conversation going after the stream. A link to that is in the description. And or you can just go to addohms.com/discord. Okay, so in this live stream, it's going to be a working live stream. So sometimes I do like presentations or demos that I have kind of figured out ahead of time. This one is very much going to be off the cuff, but what we're going to be checking out is this guy, which is the Arduino MKR VIDOR 4000. It's the new FPGA board from the Arduino team. I actually received it like 2 weeks ago, but I've been working on another project, and so I haven't had a chance to dig into it. I've turned it on one time, and it was on a different computer, so you'll get to see how I get it set up on this one. All right, so what we're going to do now is let me show you a couple of things before we get started. That's not the one I want. So I did have a write-up, and I think it's in the description link, at least on YouTube, on the 4000. It was announced at the Bay Area Maker Faire in May, and I got to play with it a little bit there and talk to the designer, and so I got to understand a little bit about the board. But the thing that I was most excited about was that they were talking about using some form of GUI to program the FPGA, and unfortunately that hasn't been released yet, which to me is kind of a bummer. So we will be doing some programming with it, but not with the GUI. Guess we'll have to do that. I guess we'll have to do that in a live stream, in a future live stream. The VIDOR is for sale now. I don't know why they say $74 and then $60, because I'm pretty sure at the announcement they said $60. So I don't know if they're just trying to be like Amazon here, or if there's plans to increase the price later. I got mine for $60 plus like $5 or $6 or something for shipping. Yeah, so you can go to the Arduino store to get that. I will probably refer to this resource. If you get one of these boards, the documentation is a little bit sparse. I'm actually going to show you a couple of issues I ran into before, but the MKR 4000 or the VIDOR 4000 subforum on the Arduino forums is really good. And in fact, the designer of the board answers a lot of questions that get posted. So there's a link to that in the description as well. And then lastly, I'm not positive, but we're going to do it anyway. I think you need version 1.9 or the beta version of the Arduino software. And so I've already downloaded that and got it running, but I haven't installed the support package yet, so we'll get to see that in just a minute. And then this is going to be the getting started guide, which is what I'm going to follow to, well, get started with the board, because it turns out I want to see if they've updated it in the last couple. So I tried this, 2 weeks ago. I want to see if they've updated what I consider a mistake in the guide, if that's been updated yet. All right, so first up, I want to say, let's take a look at what's in this package. It's actually pretty sparse. And in fact, if you saw the thumbnail for the video, you've already seen what's inside. So, static board, and then of course, Arduino stickers. And thank you for supporting Arduino. These come with all the official boards. In fact, why don't we just do this right now? I've got plenty of these stickers. Let's kind of do that. Oh, you know what? That blends right in with the background. Let's try this one. There we go. Even looks like the logo. Okay, so this is the board. Let me see if I can Let's get a little bit closer. So one thing to know, or a couple of things to know about the board. First, I didn't expect this. It comes with these ridiculously long header pins. I don't know if that's just because that's what the Maker series of boards from Arduino does by default, but this is a take it or leave it on my opinion. In fact, after the stream, I'm probably going to end up cutting all of these just because you can already see there's one here that's been bent, and I don't like these long tail headers. Maybe they're for stacking or something. Yeah. Anyway, what I did notice too is because of the board form factor, all of the labels for the pins are on the side, which I sort of wish they would do that for all of their pins. That would be really nice to have, like right on the header instead of just on the PCB. So we look inside. Excuse me, let me get something to point with. So there's a couple of chips and things. So first thing to notice is this looks like Mini PCI Express to me, and I think it is a standard connector. It's either the Mini SATA or the Mini PCI Express, but signal-wise, it's not compatible, just physically. And so I think the idea here is you could use like a standard off-the-shelf edge connector. This is the U-Blox Wi-Fi adapter or Wi-Fi chip. And in fact, the Arduino team announced a number of new boards at Maker Faire. One of them was like the new Uno Rev 2 Wi-Fi, which uses the same chip. And then there was, I thought, a third board that has the same chip. It's basically like it handles all of the Wi-Fi stuff for the rest of the board. So that's an interesting thing. That's USB. This is the FPGA. It's an Intel or Altera Cyclone. And then one of these, I can't see from where I'm looking. I'm actually not sure what this, I don't remember what this chip is. And then there's this one. This is actually the, this looks like the Atmel microprocessor. So there's actually a SAM21D. So there's a microprocessor that actually talks with the FPGA. And then I'm thinking this is the EEPROM, but I could have that wrong. All right. Okay, so you're thinking that all the new boards have them silk screened. I'll have to go look at. Oh, you know what? You're right. I won't be able to focus it, but this is an older just Uno that I picked up, and you're right, it's silk screened on here as well. So I just didn't notice that before. Cool. Hello, Switzerland. Okay, so that's what's going on the board. Now, the way this actually, from my understanding, the way this works, and you should know about FPGAs, most don't. So an FPGA stands for Field Programmable Gate Array. And so the idea is you have these logic blocks that can be configured and connected internally to perform a variety of hardware functions. So we say we program an FPGA, but really you're synthesizing an FPGA. This isn't like a microprocessor where the transistors are set for a certain function. You define those functions in the FPGA code. And usually, well, I know at least with Xilinx, I'm not as familiar with Altera, the FPGA, when it starts up, is effectively blank. And so it has to be loaded over EEPROM in order to be able to do anything. And so from my limited testing, what it seems like is going on is, maybe that's a JTAG chip, is that you program the FPGA through the microprocessor that's on board. And so that, I mean, that works. I think that's what's going on. Now, I may change that later as we get to use the board some more, but that's what I think they have happening. So let's do this. Now, one thing you'll notice that is missing is there's no cable. So that's kind of a bummer. I'm gonna grab one of these. Let's plug this in. And Oh, that's the that was the HDMI port, which actually, let me double check something. I think it is mini HDMI. Yep. All right. We might use that later. So let me pull that out. Okay, let's did it again. Okay. All right, so that's plugged in. What can we see? So let's see, this is the LED. It's a little bit difficult to see. All right, I'll just do that. Okay, so now let's go over to the laptop. And like I said, I've already downloaded the IDE. So let's grab this. And I think I want to make it about this big. And let's go into Board Manager and look for downloading index 4000. Let's go. I want the MKR VIDOR 4000. So there's been an update since I tried this last. Voltage is on. Yes, it's not as, you can't see it as well in the video, but if you look right here, you can see that there is an LED, a power LED that is active. So it is on and going. Downloading 100 megabytes. Good Lord. So how's everyone in the chat doing? I'm going to switch this over because I want to look at a few things. I want the main and overhead. Bring this back. So this looks like it's active. Hi from Facebook. All right. And then let's do another Twitch test. And what do you call it? YouTube is still running. Valerio, maybe the middle chip is for the PMIC for the FPGA. Ah, good point. You know what? While we're waiting for, I know what we can do while we're waiting for everything to download and get installed, because this actually takes a surprisingly long amount of time. So it's still installing, but I did already download. I'm hoping the schematic. Let's just take a look at the schematic real quick. Can you make the font bigger in the IDE? I'll try. I will try. I don't normally use the Arduino IDE, and so because I like a better font, but I will definitely try to make it bigger. Okay, so here's the ATmega. Like I said, it's a SAMD21. It's the same thing that's in the Arduino Zero, or a lot of like the Adafruit Feather boards are the M0 Plus. That's the same processor. That's the connector. This looks like there's a lot less pins than whatever that is. The NXP or NX18P. That looks like USB. Well, these are a lot of chips I don't recognize. Oh, okay. Maybe those were just the connectors. Oh my goodness. Okay. Well, I thought it was going to be really easy. Just look at this and say, okay, what are the chips that are on here? So this looks to me like the, I'm thinking W102 was the Wi-Fi. And then This must be the, or is it? So V out. Yeah, I think you're right. I think this is a PMIC controller. Let's just try this real quick. Yeah, yeah. Okay, so that's what this middle chip is. It is a power controller. All right, how's the IDE doing? Ugh. So I do remember when I tried this on my other computer, this step took forever. I kept thinking it was broken. All right, let's come back to the schematic while we're waiting for that. Bus, power, ground, system, battery. Is this another, was there? Oh, I didn't even realize there's stuff on the bottom. So I'm guessing that's actually where one of the power controllers is at. Man, this board is just packed with stuff. How the heck are they selling it for $60? All right. Interesting. Come on, is this done yet? No. Ugh. All right, so let's do this. If we come back to the getting started guide, it tells you to install this. Did that. Now, let's see, no, you can connect to the board using standard cables. No drivers needed. We'll be able to select it from the board manager in just a minute, and we'll do the COM port, and then we'll do blink, which it actually doesn't do anything with the blink example doesn't do anything with the FPGA. It only blinks using the microcontroller. What I'm looking for here, I'm wondering, I was totally wrong. Yeah, so this middle chip is the EEPROM for the FPGA. Well then, so this is a MIPI camera connector. I wonder if my Raspberry Pi camera is a MIPI format. I'll have to give that a shot. Okay. All right. Where are we at? No. This is making me nervous now. I don't 100% trust that this is going to work, so we're going to start a backup plan. Let's get, oh, of course, as soon as I start the virtual machine, it advanced. Go figure. Well, that was totally unnecessary. To Alliance memory, I didn't know schematics available. Good job, Arduino. Yeah, let me just show you real quick where I found the schematics. So it's on the, where is it at? So if you're on the product page, there is a documentation, like in the Arduino store, there's a documentation tab, so you can download the schematic, which it'd be nice if it was editable, or we had access to the board layout, but at least having the schematic to identify all the chips, I think that's always a huge benefit for like examples here where we're trying to figure out what things are. All right, so we got that installed. So now let's go ahead and do tools. Come on. That's not a good sign. I wonder why my IDE is lagging. Could it be that I have everything possible installed? No, that's just silly talk. All right, so we've got the Maker VIDOR. I don't know what to call this. I'm going to call it the VIDOR. All right, and then port. Well, that's a bad sign. Make sure this isn't running. Man, why didn't the serial port show up? Let me try my other port. Dun dun dun, this is not good. The serial port is missing, the serial port is missing. USB modem, okay, so this should be it. The IDE doesn't see it. Now it does. Go figure. What is HDMI? So HDMI is the digital video standard. So almost every television supports HDMI. Most monitors do. Many laptops support it as an output. And so this board can output directly to an HDMI monitor. Now it is, the port is mini HDMI, which means in most cases you'll need some kind of adapter. But yeah, that's actually pretty useful. Now, fortunately for me, my cameras use mini HDMI, so I already have a bunch of these laying around. That's a little bit too big. All right, we'll go with that for a VIDOR, but short with an EE. It's a town in Italy. Sorry about that. VIDOR. Okay. I will try to say VIDOR. VIDOR. I'm trying to remember because I actually got a chance to talk really quick with Massimo at Maker Faire, and I swear he said VIDOR, but maybe he said it because that's what I said. Huh. But yeah, he did tell me that it was he did tell me that it was a small town in Italy. So I apologize if I'm saying it incorrectly. All right, now we've got the VIDOR and the port selected. So now let's go to, come on. I should have rebooted before I started this. Let's go examples, basics, blink. Built in, la la la. I do want to double check what the quick start guide said, just to make sure we're following what they're saying. It looks like they are just using the basic one, so let's do tools, board, what am I don't even know what I was just doing. All right, so let's upload that. Now here's the thing, this code doesn't actually use the FPGA. It's only going to program the microcontroller that's on board. And so, yeah, let's see, error uploading sketch, awesome. No device found. Is this, well, that's not good. All right, so this time we're getting some red flashing. All right, so I think that's the blink, that's the LED that's actually blinking. So just like I do with other Arduino boards, so we're just going to change the 1000 to 250 and make sure that the blink rate changes. Okay, are you supposed to, on and off, upload, press the second round icon, then press upload. Get more information, sketch will be compiled and then upload it. This is weird that I'm having trouble with it. Is the programming in C++? So the programming for the microcontroller is in C++ using the Arduino library, but there are special libraries for the FPGA. And if you get down into those libraries, then you can be programming in VHDL or whatever. But the whole idea of the Arduino board is to avoid the VHDL. Okay, I'm going to try a different cable because this thing doesn't seem to like it. Let's see. Let's try this one. Hello all, I'm Jake. Okay, so let's see how that goes. That's not a whole lot of confidence inspiring right there, if my HDMI is even loose. All right, so first let's make sure the port is still there. It is. Let's try the upload. All right, this is a little, okay. All right, finally. Okay, feeling much better now. Looks like we are actually working. Okay, so here is what I noticed before is that, okay, so like I said, if you kind of look at this, let's see, Arduino, see this program, the D21, and if we look here, we're saying ARM, we're basically compiling for the ARM core. So to me, all we're doing is we're actually dealing with this guy right now. I don't know that we've actually done anything with the FPGA yet. And if we go into, say, examples, see if there's any for the board. And I don't see any here. Okay, so let's just double check the library manager and see if there is anything for FPGA or 4000. Ah, okay. Let's put in VIDOR. Okay, so interesting. Before, I feel like I had to download or install these separately. So it looks like they're at least finally in the library manager now. Let's go maker and just do a quick check. If there's anything else that I want to try to install. So I think what we're going to do, I might try and do something with the FPGA port because I can just switch my my input from my laptop to this. You know, instead of using the laptop, we can get this connected. The other thing is, let's see if we can connect to my Wi-Fi or something with the Wi-Fi examples. So now the question is, where are those at? And so, oh, you know what? I totally missed this whole section. How silly of me. Okay. Let's do, I wonder what this example is. All right. print all addresses. So it looks like it's going to print over the serial port. That's good. Okay, this kind of bothers me. Why would that be in here if this is for the VIDOR or VIDOR? So this doesn't look like it's doing anything with the FPGA. Okay, so I'm not going to even bother with that one. Examples, I2S. I don't have, wonder, are the ports for I2S called out on here? Because I do have some I2S audio amplifiers we could hook up. Let's go. Wire, master read, slave read. Okay. Let's do what I was originally thinking. Let's say Wi-Fi. Let's do this. Okay, yeah, see, this is all just using the microcontroller. All right. That's not really all that interesting. Let me try this. Let's go. Let's just start out with a blank one. Include library. Let's go. Let's see. So all right. So here we can actually see it's doing something with the FPGA, but what? All right. Let's do. Let's go cathode. Let's go find this library and just take a look at what it installed. Go to folder, libraries, see the VIDOR. What did I load? Graphics, examples. So why aren't these showing up in the IDE? That seems kind of. Let's do a draw. Let's do draw logo. Open with this. Okay, cancel over here. Interesting. That's kind of frustrating. Why aren't the examples, you know, somewhere that you can find them? Okay. Let's do, okay. So let's just do this for the moment. I'm going to upload this just because I want to see what it uploads, and then I'm probably going to move my laptop over here so that we can see it, since I'm out of input control or input devices. What are your impressions of the mini PCIe connector? Seems a bit weird. Not sure if it'll be handy. I think so without having a use in mind, the one thing I'll say is I'm really glad they're using an off-the-shelf connector. So you know, if I want to incorporate this into some kind of board, I'd prefer to use something that already exists versus having to like design my own. In terms of usability, I'm not sure yet. I need to go look at what signals are actually brought out. The only note I noticed was it talked about the USB signals, and so that's nice, but overall, I'm glad it's an off-the-shelf connector. Now, how useful will it be? Don't know yet. Okay, so uploading, done. All right, interesting. Now we're going to there was an example in the example. Okay, I'll check that in a minute. Okay, so let me do this just so that the because I don't know what's going to happen once I do this, and now we will attach. Now we will attach this. And let's try that again. No signal. Okay, that's not good. Okay. It is waiting for serial, so let me USB modem 9600. Oh, sweet. Okay, well that's kind of cool. All right, so what you're seeing on screen, so I hooked up my HDMI to here. This is going into my HDMI capture card, and the logo you see on screen, you know, up over here, ooh, that's being drawn by the FPGA. So that's cool. Now, the reason, one thing to note is in the code, okay, so I'm going to switch back to my laptop now. The one thing to notice is I did have to open up a serial terminal. I could have used serial monitor, but I like using screen instead. But because of this, the code just sat and waited. So until I opened up serial, FPGA begin never got called. So, okay, so let's kind of dig into this. So this is where I think what's going on is, okay, so the code is actually, the microprocessor is more or less doing the work. And then down here in FPGA begin, that's when the microcontroller says, hey, Mr. FPGA, go off and do something. So that's, I find that actually pretty interesting. I think that's a good way to sort of have this serial communication. And I think in a typical embedded system, you're going to have maybe a microcontroller somewhere that may be sequencing the rest of the board. So that's I think pretty useful. So let's kind of dig a little bit more into this, because this code is your standard, looks like a standard Arduino sketch, right? It's C or C++ with the Arduino library. But let's go take a look at the library a little bit closer. And so, let me just open up this. So come back to the VIDOR graphics, source. All right, check this out. Oh, wow. There's a bunch of stuff in here. All right, so I'm going to start with this guy. All right, so this is the .h. This must be the screen. I wonder what the limits on this are. Color, alpha size, cursor. Here's the primitives. You know, I wonder if they just follow the Adafruit graphics library. I mean, there's no rocket science there, but you know, maybe that's what they were thinking, is just follow what already exists, right? Colors, okay, huh? I was thinking, hey, we should try to draw the AddOhms logo, but that's going to be pretty tough. But that's pretty cool. So there's just some basic graphics primitives. Okay. So here's something I wasn't expecting to see. There's a NeoPixel. Interesting. Okay, well that would be kind of cool to drive a NeoPixel with the FPGA. All right, I'm gonna have to look into that. Let's try, okay, what else do we got in here? What is this? Yeah, actually, you know what I should notice, or what I should note, is so far this is all C code, right? Okay, so what if we go look at this C++? So that's referring to the bit stream. I wonder if the bit streams are all binaries, and that's why they're not showing up here. If that's the case, I don't even know where to go look. Vidor.io, what does this enable? Does this just enable? Interesting. Interesting. I wonder. Is VIDOR the name of the software? No, this is the Arduino. This is an Arduino board. This board is the VIDOR 4000. So Arduino came out with it's an FPGA board, and their name for it is VIDOR. Now the story I was told is that most Arduino projects internally have a 5-letter code name, and this one was codenamed VIDOR, and it ended up that it just stuck as a product name. So it's the Maker 4000 or MKR 4000 or VIDOR. The software I'm using is the Arduino IDE, and it's doing like usual, it's doing a whole bunch of stuff in the background. I'm just trying to look through some of these files and get an idea for what everything does and is. Let's take a look at what's in camera. Okay. Interesting. Disable, enable stream, right. Okay. All right. So let's see. This opened up VIDOR graphics and GFX. So GFX did the, let me back up. I'm going to back up one step. So the GFX library is what drew the actual Arduino logo we just looked at. So let's go look at the one that's just called graphics. Okay, well that was pretty simple. Include VIDOR or FPGA. So, okay, I know what I want to do. Let's go look at the C++ file and see what it includes. So VIDOR graphics included FPGA, and FPGA goes along with the C++. So it's calling for a bit stream. So in FPGAs, when you synthesize and place and synthesize, route, do all the steps, you end up with a bit stream. The idea being you're loading in all of the conditions for the logic blocks. And so this one looks like it just loads. It just loads a bit stream, and I'm wondering where that must be at. It's been a long time. When Arduino came out with this board is the first video about the board. So the board was announced in May. They started shipping them. They said they would ship. I want to give them credit because they said at the announcement they would ship in July. Now I swear they said the beginning of July, but they ended up shipping mine on July 30th or 31st. I forgot what day. So they met it. They said they'd ship in July. They shipped. The downside is the software is a little bit rough at the moment, and I think it's in a good spot to try it out. But if you're brand new to FPGAs, you probably want to wait just a little bit so that some of the software issues get sorted out. I won't even say issues. It's just it's kind of rough right now. Just like you can see what I'm doing here is I'm going through all the files trying to understand how to use this board. And you know, hey, if you think that would be fun to do, then go ahead and pick one up now, or wait another month or so for this stuff to get sorted out. All right, so what I'm wondering now is, okay, let's see. Somebody said that I missed the example on the menu. So no, I squared C, SAM, SDU. I'm not sure what SDU stands for. USB host wire. Oh. I totally missed these down here. Okay. What's this? Okay. VIDOR peripherals. Draw logo. Okay. Well, let's kind of go. Let's keep with what is this test sketch? Let's go see what that does. A bit stream, okay, so VIDOR peripherals, we'll go look at that in a second. Initialize the FPGA. Okay, so this one looks like it's going to talk to, the microcontroller is going to talk to the FPGA and ask it some stuffs. Oh, I think I see. Okay. Let's do this one. This one will be interesting. Let's upload that. Let's start with blink. We already did blink. That was actually the very first thing we did. We blinked it by default, which was 1,000 milliseconds, and then I changed it to 250. So we already did that. And then the next thing I did was I did the logo example where over the HDMI port, it actually prints or displays the Arduino logo, which is kind of cool. So we got the HDMI working. This code is going to communicate, is basically stuff running on the microcontroller is going to query the bit stream that the FPGA is programmed with. And again, I think the intention from the Arduino team is the bit streams that go into the FPGA are sort of a black box. And when I say sort of, it's going to be open source, so you'll be able to see what they are. But from a user perspective, if I want this FPGA to do things, the simplest, easiest way is to use a predefined bit stream and then interact with it, which is what this example is going to do. So let's see, it's done. Let's open up the serial monitor, change the baud rate. Oh, maybe it doesn't matter. Okay, so that's pretty cool. Let me move this over here. Let's scroll this down a little bit. So just like before, we waited for the serial to start running. Again, that's running on the microcontroller. FPGA begins, so it looks like we initialized correctly. And so the first thing we got is the VIDOR's version number. Okay, that's some kind of integer that probably doesn't mean anything to me. I wonder if it's actually like a nah. All right. So then let's see. We know it contains the extended GPIO. So let's see. Let's configure A0 to be an output. Actually, I want to copy this into my notes real quick. This was actually a question I had was, are the pin numbers on the headers may not match what you do with the FPGA. And so let me just do something here. So this is saying on the FPGA, tell the FPGA to make its pin 33, which is a 0, to be an output and go high. And then the processor is going to, so then the microcontroller is saying, okay, I want to be an input. So A0 is, and then it's going to read high or low. Okay. And then the FPGA says, hey, why don't you go back to being low? So then the SAM 21. Okay, that's cool. That's really cool. All right. Turns on an I2C interface. Okay, transfer. I got an idea for that. And then does the serial test. Did we see test? I didn't see anything that said test. Maybe it failed because oh, you know what? I bet this code failed at this point because there may not be anything for it to talk to. Well, that's funny. The direct. Okay, yeah. I'm guessing. Well, I don't know. That's weird. Same with SPI, and then it never gets down here. So I'm gonna do this. Let's modify this real quick. I2C. Print line. Done. All right, let's try uploading that and see what it does. I'm a bit afraid the board will be abandoned, as happened for many other not mature Arduino variants. Did somebody say Yoon? I would actually argue that Yoon hasn't been abandoned. Didn't it just get an update or something? I think all right. Well, that was interesting. Okay. I'm going to keep talking while I go and do a quick chat message just to make sure. Back. Oh, not yet for you guys. Okay. Yeah, so I'm going to keep going. I don't know what happened there. Sorry about that. Okay, so. All right. Let's open up the serial monitor. And I will go to 15. Let's hit reset, see what happens. I think that's reset. I don't know what that button is. All right. Interesting. It is like it. Okay. So it did get through I2C. Yeah, again, sorry about the mic. Something happened with my capture card. Okay, so we get through I2C. The thing that's interesting is it seems, let me try this before I go off and say something is happening. I hit that. No, okay. So I still feel like it is. All right, starting SPI. Can't save it. All right, And I think if I try to upload this, it's going to fail again. And yeah, interesting. So I wonder what's going on, because it seems like I have to cycle the USB, but I don't know if it's because of something that this code is doing. That's weird. I don't know if it's the code that's messing it up or if the board has an issue, but at least it seems like every time I pull out the USB and put it back in, it's working. So we'll go with that. I want to make adjustments over here. Where is main episode main image slideshow existing corner? Okay. Put it up here. Okay. All right. Now let's open up the serial monitor. Okay. So it gets down to, oh, you know what? This is the FPGA serial. So I wonder, where would we see that? Like, is the FPGA serial connected to the SAMs? Interesting. Interesting. So let's just assume for a moment. I'm gonna just gonna try this. I have no idea if this is gonna work. Let's go serial 1 begin. And while serial while 1 serial dot write serial 1 dot read if serial 1 dot available, read it, write it out, and then I want to do this, starting UART, and we'll do this, lol, just done, lol, just kidding. So what I'm thinking is this is printing something to, the VIDOR is printing something out. And it's getting, it should be connected, I'm hoping it's connected to one of the serial ports on this SAM21D. So I'm going to try echoing whatever it sees on its first serial port and see if we get it. So let's try uploading that. All right. I still wonder why I have to do that. Okay. Well, that's not encouraging, is it? I wonder what's going on. Why do I keep... Wait, is it because this is open? No. Tools, port, okay. Let's try one more time. Yeah, now it's not uploading again. All right. Let's try this another time. Yeah, okay, wow. Well, that's going to bring this to a screeching halt. I'm not sure why the board is no longer responding, and I'm not sure of what steps to take at this point. Let's go. Yeah, now I'm not surprised. So I just tried changing serial or USB ports. I'm not overly surprised that that port isn't working, so that's okay. But this one I never have problems with. All right. All right. I joined the stream and broke the board. I'm going to chalk it up to my misunderstanding of how the whole programming process works. I don't think it's necessarily an issue. I think it's just something I'm doing wrong. And it does normally seem like if I cycle the USB port, then it seems to work. So that's not a big deal. All right, let's open up the serial monitor and see if my assumption was correct. It was not. Well, that's a bummer. Okay. All right, well, that has been cool. What I want to do now is, just like we did with the graphics library, let's go look at videoperipherals.h and see what is involved, or VIDOR peripherals, and see what's involved. So the question is, where is this file at? And I don't feel like searching, so we'll just do this. So there's one in libraries. Okay, that's exactly what I wanted. So let's open up this folder, go to examples, test sketch, source, peripherals, load this guy. So it just loads VIDOR FPGA. Same sort of stuff we saw before. Okay. Cool. All right. So what I wonder is if the bit stream is different. So I notice there's a checksum here. So let's just do a quick look at this. Do I still have the old one open? I don't think so. Let's open up this guy. Nope. Graphics, VIDOR, FPGA. Yeah, so it looks like it's the same checksum. So it must be the same bit stream on the FPGA itself. So that's cool. All right. So short summary of what's going on here. So we're looking at the relatively new Arduino MKR VIDOR 4000. It's the FPGA board that was recently released by Arduino. I received it a couple weeks ago, and this is the second time I've ever plugged in and just wanted to check out what it can do. So we've actually at this point we've done, excuse me, we've done a couple of things. So we programmed Blink, which made sure that the microcontroller was working, and then we did the Arduino FPGA example, which I'm going to do again just because it's kind of cool to look at that one. And then just now we were running another, they just call it the VIDOR test sketch. And so basically it just shows communication between the SAM microcontroller, or the M0 Plus or whatever you want to call it, basically the microcontroller and the actual FPGA. And so, so far we've been able to sort of see how this works. Now, if you're new to FPGAs, this is a cool platform because a lot of the low-level coding and programming is already taken care of for you by the bit stream that's programmed onto it. If you're looking to do like VHDL or Verilog development with a board, this may not be your best option because while you can get access to the design files, the whole purpose of this board is to program through something like the Arduino IDE. And so it's really more of a, we use the Arduino code to say, okay, let's program the FPGA and then let's interact with that FPGA. And so it's just a different way to do FPGA development. So with that said, I know there's some new people that haven't been here the whole time, so I'm going to go back to this other example just because I think it's, let me see if I have it open, just because I think it's a little bit more interesting. So it's already, let me close it so we can just start fresh. Examples, VIDOR graphics, VIDOR draw logo. And then let's look at this code real quick. And so the idea is we open up this serial port, and that's going to be on the microcontroller. And then FPGA begins, and then it does something with the FPGA. And down here in loop, we can see these drawing primitives, which are going to draw something interesting on the screen through the mini HDMI. So this is going to be HDMI. Now what I'm going to do is I'm actually going to just borrow the HDMI connector from my laptop, plug it in here so that you guys can see what it's doing. So first what we'll do is try uploading. Let's see if I get another error. Okay, this time it's working really well. Chip is available FPGA, so it's not as easy to prototype unless you have an oven SMD set up. Yeah, actually, upcycle, and I mean, unless you have what I would call a real reflow oven, it's difficult to work with BGAs. My toaster oven, which I've shown in a couple videos, I don't know that I could do BGAs with it. Okay, all right, so no, still uploading. Once the uploading's done, I'm going to switch the cables around. Interesting. Okay, and it's done. So let me just do this. Move this around, plug this in. All right, let's go to, all right, so all I did was move the HDMI over here. We're going to have a color bars pattern until I open the serial monitor. And there we go. So the FPGA is actually drawing. There we go. Look how clever that is. What happens if I hit this? Yeah, I'm thinking the push button doesn't do what I think it does. Or maybe it does. I forgot. You have to open up serial. Okay. So I wonder, is this a bitmap and then this is the actual code that draws it? Either way, that's really cool. But yeah, so the FPGA is actually drawing that over HDMI for us, which by itself I think is just a really cool demo. So I'm going to go back to my laptop now. Wait for that to wake back up. All right. Okay, so yeah, so I think, you know, for me anyway, I think that was pretty cool, being able to see the FPGA basically draw some graphics. Hey everybody, I just joined. How much does this Arduino cost? So this Arduino is $60. So let me show you a couple of things. Like I said, I wrote this up. This was back in when the Maker Faire, when it was announced at Maker Faire. I'm really excited that it started shipping on time, and so that's pretty cool. If you go to the Arduino store, you can see that it's available for $60. It does have a lead time associated with it. It is a new board. It just started shipping, so don't expect to get it overnight. In terms of getting help, I highly recommend the MKR VIDOR 4000 subforum on the Arduino forum. That's going to be the best place to find out information about the board. And then I'm using the beta IDE. I haven't tried it with 1.85. I've just been using the beta the entire time. And if you follow the quick start guide, you do need to install some board support as well as a couple of libraries. So it's relatively easy to get it up and running. So like I said already, we've done 3 things. We've kind of tested out the board, tried out some of the examples. I think at this point, I'm going to start winding down the stream. I do plan to come back and do another stream with the board. I'd really like to get into things like the SPI peripherals, maybe I2C, sort of do something with the board other than just the HDMI. In this stream, my goal was to basically turn on the board, get it all set up, and see how it works. And now I've got a really good understanding. It really does look like the way that this works is you use the microcontroller to more or less control the FPGA, which is a really cool way to do things. And so I just now at this point would like to explore more what can we do with it. And so I'll probably look at some other peripherals to plug into it and find something interesting. And then in the next day or so, I'll do another live stream. I'm going to stick around. I'm going to start to shut down the stream, but I'm going to stick around in the chat. A couple of things to remember. Again, my name is James. I'm the Bald Engineer. This has been an AddOhms live stream. For more streams like this, as well as stuff like electronics tutorials and projects, please subscribe to the channel. If you're on YouTube, my stats say that only 20% of you are actually subscribed, so think about that. You can also follow me on Facebook and Twitter. Not Twitter wasn't what I was trying to say, Twitch. Now on Twitch, I'm set up as Bald Engineer instead of AddOhms. I may change that in the future. Lastly, if you want to keep the conversation going, I do have a Discord server set up, so feel free to jump into that. The link is in the description, or you can just go to addohms.com/discord. All right, so let me look at the last couple of chat messages, and then like I said, even after I put up the thank you message, I'm going to stick around in the chat room and talk for a little bit more. Dave says, no problem, David. Thank you for all the work that you do on the Arduino team. It's makes me a little bit nervous to see you join. The FPGA could act as the main CPU over the SAM, not only as a peripheral. Yeah. I mean, it could. I'm just taking a guess. This is my opinion. I think the board is set up this way just to make it easier for the user to interact with it. But I could imagine you could design the FPGA to do all the same stuff the micro is doing. It's just, it's basically acting as a programmer in most of the cases. So you'll be able to program some things from the FPGA side and more advanced stuff with the future block editor. That's probably a good question for David or somebody else. My understanding is yes, but we'll see where that's at. All right, cool. Well, thank you, everyone. Like I said, I'm going to stick around and chat for just a few more minutes, and feel free to ask questions or join the Discord. Have a good day. If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon.